Good morning, friends. Now, in this section, we are going to discuss for the finite state machines. We will give some basics about the finite state machine with suitable example. So the overview of this section is, so what are the types of finite state machines? After that, so we are comparing the finite state machines of the Melay, Moore, and we are giving the one example for Melay machine and also Moore machine. First of all, define the state diagram. The state diagram or state graph is the pictorial representation of relations between the present state, input, and next state. And it also has some output value. So mainly we have taken the input state, output state here. Sometimes the output state value depends upon the input state value and input values here. And so first of all, we are going to discuss about the Melay circuit and Moore circuit. The definition of the Melay circuit is, in this model, the output depends upon the both present state and input of the flip-flops. And whereas in Moore, the output depends upon the only present state value, not on the input values. In equation representation, Z of t, that is output, is the function of present state and also input value in the Melay machine. Whereas in Moore machine, the output is the function of only present state. And these are the few differences between the Moore, Melay here. In Moore, the output depends upon the only present state as per the definition. And in Melay, the output depends upon the not only present state but also depends upon the input value. In Moore, the output does not depends upon the input value, so the input, even the input changes, it does not affect the output value here. In Melay, whenever the input changes, immediately it affects on the output value. And the Moore requires the more number of states here, whereas the Melay requires the less number of states. And it is the Melay model. Whereas, so whenever you see here, the output value depends upon the not only present state values, but also depends upon the input values here. These are the input values, and the inputs are connected to the output value. Whereas this is the present state value. Let us see a small example. It is a state diagram. It is a 0, 0 state, 0, 1, 0 state, 0, 1 state, and 1, 1 state here. So whenever you are seeing the diagram, the 0, 0 state has the two moves, one for the 1, one for the 0. So whenever the state is 0, it is going to the same state and the output is 0. Whenever the condition is 1, it is moving to the 0, 1 state, whereas the output is 0 here. So we are representing the same state diagram with respect to state table here. Let us see in the next slide. So from the here, just move the state here. So it is a 0, 0 present state. And so whenever the x is 0, it is going to the next state of the 0, 0, and the output is 0 here. And whenever the 0, 0 state, the condition is x is equal to 1 value, it is moving to the 0, 1 state, and the output is 0. Similarly, we are drawing the state table for the remaining states also, for the 0, 1 state, 1, 0 state, and 1, 1 state here. After that, so from the K-map, if you design this state table, so we'll get the logic diagram, and it is a logic diagram. So we can use the either D flip-flop or T flip-flop or JK flip-flop. So depending upon the requirement of the flip-flop, so we can use the type of flop here. And coming to the Moore machine, here the Moore machine, the output value depends upon the only present state value. So we are not connecting the input value to the output connections here. And it is an example of the state diagram. So when you see the difference between the Melay comma Moore, in Melay, so we are representing the output value in the transition period. But in the Moore, so we are representing the output value within the state here. It is the 0, 0 per 0. Nothing but the output is the constant for the each every state. And the 0, 0 state is moving to the 0, 0 state when the condition is 0. And the 0, 0 state is moving to the 0, 1 state when the condition is 1 here. Okay. So similarly, you can draw the state table. Okay. And it is the state table. As per the output is constant. So for the 0, 0 state, the output is 0. 0, 1 state where the output is 0. 1, 0 state, the output is 0. 1, 1 state, the output is 1 here. And we are taking the same condition for the 0, 0. It is moving to the 0, 0 state when the condition is 0. The 0, 0 state is moving to the 0, 1 state when the condition is 1. And whenever you solve this table with respect to K-map, you can design the same circuit with respect to as per our requirement flip-flop here. So here we are taking the some D flip-flop or JK flip-flop, and we can design the circuit here. Okay. And in the previous case, we have taken the D flip-flop. Here we have taken the T flip-flop here. Okay. And thank you very much. So it is only the overview of the finite state machines, Melay machine and Moore machine. Thank you.